All right, so let's talk about isotopes, okay? So honestly, guys, these are really easy when it comes to the basics, okay? So isotopes, if you have not heard of them before, are just atoms with the same number of protons, but different amount of neutrons, okay? Remember, protons and neutrons are in the nucleus. So in other words, based on what we learned about Ape Man, they would have the same atomic number, protons, right? Different mass numbers because of the neutrons, right? Because remember, protons and neutrons carry the mass and they are in the nucleus. Therefore, neutrons would be different, okay? So why are they important? So mainly, guys, once we get into nuclear chemistry, this is where they are very important. It's based on what we talked about with radioactivity. Do you remember what radioactivity was when we talked about lab safety? If not, just a little quick review here. So when we have the atom, right? So here's my nucleus, and then this is my little atom, all right? So remember that with radioactivity, what causes radioactivity is the decay of the nucleus right here. Decay meaning it's damaged over time, something gets lost from it, either protons or neutrons it decays, it worsens over time. Meaning, and when that happens, when those protons or neutrons are lost, it emits this energy, this harmful energy called radioactivity. So we will get more into nuclear decay later though. So, but that's just to show you quick importance. Now, what do isotopes look like? So you will see them in two different kinds of ways. One way is like you see here, not exactly X, A, and Z. These stand for something, just like in math. So you'll normally see this X being the element symbol. So like hydrogen is H, helium, He, okay? This A, and I know it's kind of confusing. Remember, it's kind of like X and Y, what they stand for in math. It's kind of similar here. So this top number is known as the mass number. Remember, protons plus neutrons, okay? And then this Z, or the bottom number that you would see, is the atomic number. And hopefully that's not super confusing, because I know when you see A, you might be like, oh, atomic number. No, atomic number goes on the bottom, mass number, okay? So it can also, besides that, can also look like this. Sometimes they'll show you carbon 12, carbon 13. These numbers right here are the mass numbers, okay? So keep this in mind though, and I put a little note right here. Mass number is not the exact same as atomic mass, and we'll get into that more once we get to average atomic mass on, eventually for pre-AP it'll be on Friday. So these are some examples of, like, again, what it could look like. So for hydrogen, you can see it like this. So hydrogen would have, this would be the atomic number on the bottom, right? Based on our little diagram here. So therefore it would have how many protons? 1. And this top number would be the mass number. So if I'm trying to find neutrons from this, I would just subtract 2 minus 1, and we would get 1 for how many neutrons this particular isotope has, okay? Helium, you'll see it like this or this, okay? Lithium, you'll see it like this. Again, atomic number is on the bottom. Atomic number is on the bottom, and then mass number is on the top. So notice, again, we're kind of following this little diagram. Again, these each stand for something. So here's element symbol, mass number, atomic number. Straightforward, right? Okay, so practice how to calculate each of the subatomic particles based on like what we did with Ape Man if I'm given an isotope. So what if I'm given only part of it? So I'm given this number up here, which according to this diagram is the mass number, right? So I'm given 10, and it's like, oh, wait, I don't know what the atomic number for boron is, right? So Then I'm going to look at my handy dandy periodic table and notice that the top number, the atomic number, is 5. Okay. So then I can just fill that in. So my mass number we said was 10. And if my atomic number is 5, I know that protons and what else? Electrons are also 5. Okay. How do I calculate neutrons? I take the mass, remember from Ape Man. Okay. Mass minus atomic number equals neutrons. So I'm going to take 10 minus 5, and that equals 5 as well. Okay. What about if I have it in this kind of way? Again, I'm only given the mass number, right? So I know I'm going to look up the atomic number of chlorine, and I realize that its atomic number is 17. Okay. So if its atomic number is 17, I automatically know the protons are 17 and that the electrons are 17. Okay. And then I'm going to take, for the mass, I'm going to take 35 minus your atomic number, right? Oh, sorry. For neutrons, I'm going to take the mass minus the atomic number, and we get 18 with that. Okay. And the mass is obviously 35 because that's given to us, right? Hopefully that's simple enough. So this is part 1 of isotopes. We will talk about what about average atomic mass? What if I'm given a percent abundance of some of these isotopes? How do I calculate an average atomic mass? But we'll get to that more later. Okay, hope this helps.